my channel, STEM Cafe, where we make everything science, technology, engineering, and mathematics easy to comprehend, assimilate, fun, and entertaining. Today we are treating an entertaining aspect in mathematics. We refer to them together: permutation, combination, and probability, because they are very related. You see, when you are talking about logic, when you are talking about reasoning, it's very good you understand this topic: permutation, combination, and probability. You know, generally mathematics, science about reasoning and logic. But this one, you know, it requires concentration and it's fun, just like playing chess. And if you can really understand this, I can assure you, you see it as fun. But if you don't take your time to understand it, you rush to read it and you rush to go and answer questions. That's why some people get frustrated. Relax. Let's enjoy the ride and every bit of it. Don't just enter the ride to get your destination. Enjoy the other side attractions along. Now, let's look at permutation. Permutation is mainly about arrangements of objects. You know, let's say we have objects A, B, C, D, and we want to arrange them. Permutation will make us to really understand how we can arrange it, how many times, in how many ways can we arrange it. That is the main thing about permutation. I am concentrating mainly on permutation now. Now, if you look at this, you have A, B, C, D. If I want to arrange it again, I can still arrange it again as A, B, D, C. That's another arrangement. So they are still the same objects in the same set, but I have rearranged them. Look at this again. A, B, D, C. Now look at this. A, C, D, B, D. A, C, D. By the time you continue arranging this, you will see that you can arrange it in 24 ways. 24 ways. 24 ways. Now, if you look at this, I have arranged it. You see that the arrangement differs. I started here with A, B, C, D. So, if it is 5, 2, you have to do it in this like manner. Now, let's look at if I have just 3 objects. A, B, C. So, I can have A, C, B. B, A, C. B, C, A. C, A, B. D, C, A, B. C, D, A. Now, look at this. If it is 4, I have 24. If it is 3, I have 6. So this one is 24. So there is one thing about it. When we have objects like this, and they occur once, we are not repeating it. What is the science behind the arrangement? It's very simple. Since we have 4, we are going to arrange them. We call something fundamental counting system. Fundamental counting systems means that we have 4 places to put them. We have 4 places to put them. For the first part, how many of the objects can we put in this place? You see, I have A, B, C, D. Which means that from this I can select 4. 4 can stay here. Once I select one of them, you know, out of this 4, I can just pick one of them. So which means I have 4 choices. Now, it can be any of them. Since I have taken one of them, I don't put space on it again. Let me just make it like this. So it will be like I have already picked one. So here now, any of them can be A, B, C, D. It can be B, C, A. So let me just pick one. How many is left? 3. In this second place, I have 3 that I can put here. You can see. So once I have taken 1, it means how many? 2. So now I can put 2 here. How many remains? 1. This is fundamental counting system. So now multiply. 4 times 3 times 2 times 1. What does it give me? 4 times 6, 24. So for this one, that is the simple way of reasoning about it. The most important part in this permutation, for me, is this fundamental counting system. Because either way, anytime you get to any, you hit the wall, just go to the fundamental counting system. You will get your answer. You will wriggle your way out. Now let's look at when it is 3. Now look at it. When we have 3 objects, which means that we have 3 places you can put them. You want to put them. In this instance, sometimes it might not be up to 3. Now, if I have it like this, I have 3 options, but it can be any of them. So let me just make it like this. So, in the first place, how many options do I have? I have 3 options. I pick one of them. Now, for the second place, how many options do I have? I have 2. I have picked one now. Remaining 1. So, what do I have now? 6. just like this. So I believe you have understood this now. Any other one we want to do, we always refer to this counting system, but it might not be straightforward like this. But know this one. So this counting system, we have been able to shorten it. And that is where we have the what we call factorials. You see, just like we have logarithm, we have sine, we have every other function, we also have factorial. And this factorial makes it possible, easy for us to handle permutation and combination without writing it in log form. Just like instead of writing 2 plus 2 plus 2 in 20 times, we just say 2 times 20. So in the same way, instead of writing 3 times 2 times 1, or if you have objects as many as 10, instead of writing 10 times 9 times 8 to times 1, we write 10 factorial. Do you understand now? So factorial means when you have n factorial, what does that imply? It means n multiplied by n minus 1 multiplied by n minus 2 n minus 3 multiplied until you get to 1. That is what factorial is for. Factorial is a shortened form of this long multiplication. Just like we have this. You understand? If you have numbers like this, and you say r from r equals to 1 to n, you know, it's going to give you, you start like 1 plus 2 plus. So the same way factorial exists. Now, let's move to other things. So, for that one now, we are talking about how to arrange objects in a row. Arrangement, different kinds of arrangement. That is what you have just done. So, when you are talking about, like if you have n objects, and you want to arrange them in a row, arrangements in a row. The number of arrangements, number of possible arrangements. From what I have just described, from the arrangement I showed you before, it's going to be equal to n factorial. Let's look at this. How many ways can 5 different objects be arranged in a row? From what I have done, instead of writing counting and counting again, all you just need to do is to say 5 factorial. Or we just do it from the counting system. So for the first box, you have 5 objects to pick from. For the second object, since you have picked 1, you have 4 objects to pick from. For the third side, you have 3. For the fourth side, you have 7. So for the last one, you have 1. So, and you see, it is 5 factorial. Very simple and straightforward. Now, in this instance, we are talking about arrangement where we have identical objects that you cannot differentiate. Let's look at this word, margin. Yeah, margin. You see, if this is M1 and this is M2, you know, ordinarily, I won't be able to differentiate this M from this one. Ordinarily. Now, M margin is still the same thing as M2 AXI M1. Look at this. This one and this one are still the same. But either way, they must form the same arrangement. How do I mean? They must have arrangement with still the same 5 contents. Therefore, it will be like I have, let me see, 3 different and 2 similar things. Yet, I have to form 5 arrangements with 5 objects. Now, look at this. I have MAXIM. MAXIM again. I can still say this one. MXIAM. 1, 2. M2 XIAM1. You can see, I am having the same thing, but in different reasoning. It's only somebody that is handling it. You say, okay, oh, this one seems different. But ordinarily, they are not different. Because this one script do not exist in real life. Now, these ones now, if ordinary arrangements, if all of them are non-identical, the real arrangement if non-identical, it's going to be 5 factorial. You understand? But now, I have 2 identical. How many of them will I be able to find? I'm going to have the identical will form 2 factorial arrangement. So, in the real sense, at the end of the day, because of the identical objects, in this instance, the arrangement is equal to 5 factorial over 2 factorial. Very straightforward. So, whenever we are forming anything like this, we will look at how many of them are similar. We will form the factorial of them under. And then put the factorial of the total elements available or objects on the top. We have maximum. Now let's look at this one. Maximum. Maximum. If you look at this, to find the number of arrangements or possible arrangements, we are going to have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we have 7 factorial. How many identical objects do we have there? 1, 2, 3. Divided by 3 factorial. In this instance, you have no problem. Just look at how many are similar. How many is the total arrangement? Let's look at another simple one. Look at this word, arrangement. If you want to find number of possible arrangements, Okay, sir. Yes, number of possible arrangements. How many letters do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11. Now, due to the similar objects, let's look at how many identical objects we have there. Look at 8, we have 1, 2. 8, we have 2. R, we have 2. N, we have 2. G, we have 1. E, we have 2. C, so we have A, R, N, E, M. So the ones we have 1, 1. Let's look at it so that we balance. G, 1. N, 1. C, 1. So it's okay. We have 8, 2, 2, 1, 1, 1. So with this, we can easily get our answers now. So the answer is going to be 11 factorial over 2 factorial, 2 factorial, 2 factorial, 2 factorial. So our answer is easy now. Because if 8 are all identical, we will say 8. But in this instance, we have two different ones that are identical. So we don't need to put 1, 1, 1 factorial because you know the factorial of 1 is 1. So that is how it is done. So this one is very easy and okay now. Let's take another thing under permutation. Now let's look at permutation of R objects from N objects. You know, if I want to pick R objects from N objects, automatically N will be bigger than R. Now, let's look at something like this. If I have 8 fruits, different fruits, and I want to pick 3 fruits, how do I go about it? Best thing is to go with the fundamental counting system. You know, since I have 8 and I want to pick 3, which means that I have 3 boxes to fill. So what does that imply? It means that I have 8 to start with. So if I should pick 1 from these 8, how many options do I have? I have 8 here. How many options do I have left? 7. Because once I have picked 1 of it, I have 7 left. I have picked 8 here. In the second place, what do I have? I want to pick 1 from this. How many options do I have? I have 7. Since I have picked 1 now, this one has reduced to 6. You can see. Now, again, I pick 1. How many options do I have there? I have 6. So that is it. So the arrangement, possible arrangement to pick 3 fruits out of 8 different fruits is 8 times 7 times 6. And how do we express this in factorial form? If you look at this, it's going to be 8 answers we have got. So which means for me to delete this part out, I'm going to have 5 times 4 times 3 times 2 times 1 out of this to get this. So what does that imply? It means that if I have this arrangement to make, I'm going to make it like this. 8 factorial over 8 minus 3 factorial. You can see 8 factorial over 8 minus the number of objects I want to pick. That is the factorial. And how do we express it in permutation language? It's going to be 8 permutation 3. So that's how it is expressed. You can see. So if I want to pick 3 fruits out of 8, I'm going to have 8p3. And that is going to be 8 factorial over 8 minus 3 factorial. So if you want to extend it to be general, I'm going to pick r objects from n objects. So that's going to be npr. And that will give me n factorial over n minus r factorial. Simple. You can see. Very simple and very easy to handle. Now let's look at permutation with restriction or conditional permutation. In this instance, they will give us certain restrictions or tell us that, okay, this happened to 1, this happened, or this should not happen. That is what we refer to as conditional permutation. They might tell us some of them cannot hold certain position, or some of them cannot be at the end or at the beginning of the line. So that is what we refer to as conditional permutation. And for you to find it easy to handle conditional permutation, you investigate those that have that restriction first. Investigate them, or investigate the ones that condition will not touch at all, and then you can subtract from the total possible arrangement. This is very, very interesting because it requires your thinking, and you cannot easily rush to generalize the workings of this permutation with restriction. Just try to, investigate the ones with restriction, and then you can work every other thing out. That fundamental counting technique is very, very useful in this case. Let's look at 1 or 2 examples to explain it. Now look at this. It is a conditional arrangement. Find the number of ways of arranging 6 men in a line so that A, the oldest is at the far left. B, the 2 youngest men are at the far right. C, the shortest man is at neither end of the line. Now if you look at it, we have 6 possible items to pick from. And all of them must be on the line. And I want to assure you that many of the questions we solve will come under this condition. Conditional, restriction, and selecting from that we did previously. Here I have 1, 2, 3, 4, 5, and 6. We are told that the oldest is at the far left. And since it's the oldest, it can be only 1. So which means that at this point you can only put 1 here. If I have removed the oldest, how many remains? It remains 5. So which means that for that first one, that's the only condition we are given. In the second place, I have 5. Now I have picked 1 of it. It remains 4. In this place, I have 4. Again, it remains 3. In this place, I have 3 to pick from. Again, in this place, I have 2 to pick from. I have 1. So the total possible arrangement, if the oldest must be here, is going to be 1 times 5 times 4 times 3 times 2 times 1. So for this first one, A is going to be 1 times 5 factorial. That's the answer to A. 1 times 5 factorial. That's it. Very easy and straightforward. Now let's look at the second one. He says the 2 youngest men are at the far right. Again, I have 6 people to pick from. So they are telling us that at this point, we have 2. So here now, it remains very easy to look at, which means that 2 people are separate now. I have 4 and 2. So in this place, I have 2 people to put here. So it means that here I have 2 and here I have 1. You can see from these two now that I can pick from, I can put 2 in the first one. I can pick, as in, I have the option of 2 here, option of 2. So after I picked one out of it, I have 1 left. That one is gone. Now for this place now, I have handled 2 out of the 6. I now have 4. So it means that 4, 3, 2, I pick another one. This one, 1. So this is the answer. So what does that mean? This one is 2 factorial, and this one is 4 factorial. So for the second one, you can see I'm not just writing factorial. I'm explaining it. So it is very easy for us to handle it. So this one is going to be 2 factorial times 4 factorial. So this one is 120. This one is 2 times 24. This one is 48. Now see, it says the shortest man is at neither end of the line. It's at neither end of the line. So once again, I have 6 people. And I have to investigate the restriction first. 1, 2, 3, 4, 5, 6. Now, what is the situation I have now? For this point, I have option of 1 and 5. 1 can neither stay here nor here. So what does that mean? For this point, I have option 5. For this point, I have option 4. You can see. So what do I have remaining? 4. Because I have picked 1 and 2 now. So for this middle point now, what remains? I have 4. For this middle now, I have 4. Because 1, that shortest man, can neither stay here nor here. So which means that out of the remaining 5, I should pick for this place and this place. But in this middle, any of them that remains can stay here. So I can now have in this place 4, 3, again 2, and 1. You can see. So it is very, very simple. I investigated the restriction first, and I went for it. They cannot stay here. The shortest man cannot stay here nor here. So I abandoned that place. Now the remaining 4, because out of the 5 after the shortest man can stay here. So I have this. So my answer is now going to be, if you like, you can make it 5 times 4 times 4 factorial. That's it. This one times 4 factorial. Now you answer. So you get to be 20 times 4. So that's the arrangement for this one. Now let's look at this. It says how many odd 4-digit numbers greater than 3,000 can be made from the digits 1, 2, 3, 4, each used once. You know, if you look at it, that is one joy of permutation. You have to think deep. For you to have 4 digits, and for all these ones to be greater than 3,000, it means that the first one must be greater than 3 or equal to 3. Since there are 4, this one must be equal or greater than 3. Here. At the same time, we have another condition. It says odd. Odd. These are the conditions we have. We have 1 and it says odd. It means that this place, from these numbers we are given, we have 2 odds. And the odds must end this place. So which means that this place can be 1 or 3. So this place, it means that this place can be 4 or 3. Now, you can see that we have a condition here, you know, intermingling with the condition here. 3 here, 3 here. And the problem now is, if 3 is here, 3 cannot be here. So it affects the conditions seriously. So we have to look at it in 2 critical ways. When 4 starts, what happens here? When 3 starts, what happens here? Now let's start with when we have 4 as the number here. So what happens? When we have 4 here, we have 4. That is 1 here. Can you see? It means that this one is out of it. Which means that here we have 2. Possibly 2. So which means that we have either 1 or 3. So we have 2 here. So what remains? We have 2. We have 2. Now, so it's either either we pick 1 or 3 into this place. So that one has given us 2 here. So which means that either 1 or 3 goes. So let's say 3 goes. So which means that in this place, either of these places, we have 2 and we have 1. So here we have 1, that is 4. Here we have 2, that is 3 or 1. So since 3 or 1 can stay here, which means that one of them still remains. So which makes the remaining numbers to be 2. So we have 2 here, we have 1 here. So if 4 is the first number, possible arrangement will be equal to 1 times 2 times 1 times 2, which is 4. You can see that is 4. Now let's look at it. When 3 is now the first number, here we have 1, 2, 3, 4. When 3 is the first number, that is here we have 1. It means that the last number can only be 1 now. We have 1 here. Please follow. If 3 is the first number here, the last number here can only be 1. So 1 also will appear. So what happens? We have 2 and 4, which means we have 2 numbers left. So we have 2 times 2 and 1. So we have this. So if 3 is the first number, possible arrangements will be equal to 1 times 2 times 1 times 1, which is equal to 2. So total possible odd numbers greater than 3,000, we have this 4 plus 3. So total possible odd number greater than 3,000 is equal to 4 plus 6. We have a lot of questions under this topic, under this restriction, and I'll dedicate another class to solve enough questions. So let's see if we can move on from this place. Now let's talk about a situation where repetition is possible. That is, a number or anything, you can still select it again. It can be returned back and be selected again, especially figures or letters. Let's say we have this letter A, B, E, T, and we want to form maybe 3 letters or 4 letters, 4 letter words or 3 letter words, and we want to, and it is possible for us to repeat the same letter. Just like if I am forming 3 letter words from this. You know I have 4 letters already here, 4 here, but I want to form 3 letter words. If I pick the first one here, how many choices do I have to pick in this place? I have 4. But let's assume, out of probability, I took the first one and I return it back. I took one, I return it back. How many choices are there for me to make in the second one? It is 4 again, because I have returned it back. That's what it means. And this one again, I return it back again. So, the number of possible repetition will determine how this one will be. So, if repetition is allowed, it means that are possible length of arrangements. Permutation or possible arrangements will be equal to n e to the power r. Just like when you are gambling or anything, you have 9 numbers to select from, and you are allowed to repeat or anything. You see, you can see how many numbers can be formed. If you have 0 to 9, you know you have 10 digits, and you are going to play, lottery. That you are going to choose 5 figures. 5 figures. So, if the arrangement, the order of arrangement is important, it means you can have 10 raised to the power 5 arrangements. So, please, before I go on, I want you to know something. In permutation, the order of arrangement is very important. Like I have told you before, A, B, C, D is different from A, B, D, C. It's different. So that is the thing about permutation, which means that if your lottery is 1, 4, 5, 8, 9, and you play 1, 4, 5, 9, 8, if they are different, you understand what it means. So for this is the possible number of arrangements when repetition is allowed. So for this one, the total possible permutation or arrangement is going to be 4 raised to power 3, because we are trying to form 3-letter words from A, B, A, T. So it's possible. So that is the answer to this. Now let's look at another interesting one. Now let's look at arrangement around circular objects. That's another funny aspect. This one really made me to think a lot before I got it. But from our own perspective, you get it very easy. Now, let's say we have 5 objects. If it is on a straight line in a row, you understand? If it's in a row, the arrangement for the 5 objects will be 5 factorial or 5e5, 5 permutation 5 in a row. Now, let's look at it when it is around a ring, a circular object like this. Let's say the objects are A, B, C, D, E. You see? And the funniest thing about circle is, either way you look at it, it's so funny, you will see it in one way. Look at this. If A comes here, it's standing in one position. If it comes here, around the circle, it will still be like 1. It can only occupy that 1. Let's put it that way. Now, if I bring B, it remains 4. Let me remove A now. It remains 4. If I bring B, or C, or D, or E, let's place it. Where will I place it? Can you see? If I place it here, it's still B. It's still A. Can you see? If I place it here, because it is circular, it can still be seen as A, G. If I place it here, it can still be seen as A, G. You understand? In as much as I look at it from one perspective, can you see? I look at it in clockwise direction or anti-clockwise direction. So you can see AD. Throughout, if I place it here, it is still AD. So in this instance, AD or DA is still the same thing. It's still the same thing. Now I have removed A and D. Now, if you look at it now, I have placed them in that position. Let me now put it like this. Let me put D here. It's the same thing. Let me now bring B. Where will B be? B can be here. A, B, D. Again. Can you see? A, B, D. You can see. A, B, D. Now, if I look at it again, I put B here. Now, A, D, E. So, which means that B or C or E can occupy 2 positions now. You can see. So, I have put it here now. B, D. So now, B. So it remains 2 now. What I'm saying is, anyone could have been A, anyone could have been D. Do you understand? I just say, but I pick them so that it will be clear for one arrangement. So, look and see now, B can occupy 2 positions relative to these ones. It can either be here or here. Either here or here, no matter how close I make them to be. If I bring this one here, all this place is 1, and this place is 1 again. So you can see. So this one is 1 times 1. Can you see? B now has occupied, it has opportunity of occupying 2 places. So that is 2. Now, I have C and E. In this instance, I have 2 remaining 2. Where can it be? So that the place it will be, it will give me a different arrangement. If I put C here, I have A, C, D, B. All through this place. You can see. All through this place. A, C, D, B. If I put C here, I'm going to have A, D, C, B. You can see it's a different arrangement now. So it means that it can be here, it can be here. If I put it here, it's going to be A, D, B, C. You can see. So I put it here, ACEDB, can see that's a different one. That's another one. If I make it like ACDEB, that's another one. Placing it here. So ACDBE, that's another one. So I have 1, 2, 3, 4. So you can see. So if it is arrangement around circle, the number of possible arrangement or permutation will be equal to n minus 1 factorial. You can see n minus 1 factorial because of the peculiarity of the circle. It took me a long time for me. It took me a long time to get it because I was just putting the objects together. But later on, when I view it, I realized that either way it is, no matter how close they are, the position still remains the same. But if you can turn it or you can look at it backward, you understand? Like if it is a ring or a twinklet or anything, permutation, when it can be looked backward, like in ring, that you can turn upside down, it's going to be n minus 1 factorial over 2. N minus 1 factorial over 2. What do we mean? Look at this one. A, E, B, D, C. You understand? So, which means that if I have placed E here, place it here, B here, and C here, it will be the same thing. You understand? So, which means that I have done the same arrangement twice. That is why we have to divide this one by 2. So, thank you very much. I still find arrangements to answer enough questions under permutation. But with this, with what you have done, you should be able to practice and get enough. If you have any questions, kindly use the comment section and assist this channel to go viral. If there's anything you feel like you need to advise, you can contact the channels to do that. It's in the description. Thank you very much. I appreciate it. So far, and any other topic you feel like will assist, it's very necessary for us to learn. Communicate with us. Share, comment, subscribe if you haven't, and do everything you know